Continuing with example 7. Alright, so now we're looking at a graph. Last time we looked at a table. Now we're looking and we're using our visual clues to kind of help us here. On what open interval is f decreasing? Okay, remember f decreases. We're looking for the places when f prime, whoops, is negative. So where is, this is f prime, remember, from 0 to 1, f prime's negative, and then also from 6 to 8. And we're justifying since f prime of x is negative. At what values of x does f have a local max or min, and justify? Now remember, for max or local max or min, we're looking for where f prime changes from positive to negative or negative to positive. So f has a local max at, okay, looks like 6, since f prime changes from positive to negative there, and f has a local min at x equals 1 and x equals 8, since f prime changes from negative to positive there. On what intervals is f concave up? All right, so we need to know where f double prime is positive. So now we need to look at the slopes. So here the slope is positive, here the slope is positive, and here the slope is positive. So f is concave up like a cup from 0 to 2, also from, looks like 3 to 5, and then from 7 to 9. Okay, just making sure it only went to 9. And the reason we know that is, since f prime is, that's f prime, just one, is increasing. Okay, state the inflection values of f. All right, so now we're going to look at the graph. We already put the concave up parts. So where does where does the concavity change? Where does f prime change from increasing to decreasing? So it looks like that would be at x equals 2, at x equals 5. Oh, also 3. Let me go back to that. I missed one. All right, so we'll try that again. At x equals 2, at x equals 3, because f prime is changing from decreasing to increasing. And then at 5 and 7. And that's since f double prime changes signs. All right, now this is maybe the hard part. I'm going to clear off this graph. And I guess we'll go black here. Assuming that f of 0 equals 0, got that point. Sketch a graph of f. All right, so we have to look at all the things that we had so far. F is decreasing, we have from 0 to 1, and it's also concave up. So maybe we'll have something like this. And then let's see, where it from 2 to 6 it's increasing, but it kind of changes. So from, looks like 2 to 3, we're going to be concave down, and then 3 to 5 we have to be concave up again. So we're going to go concave down, and all the way to 5 we're going to go concave up. Okay, and then looks like we're concave down again until 6, and then we stop increasing. So let me make it less bold. All right, let's try that. So we said this, concave down, concave down, concave up to 5, and concave down again. All right, so something like that. Now we're going to decrease from 6 to 8, and we're still, until 7, we're going concave down. So we're going concave down, and then concave. Oh, I wish I connected that. We have a continuous graph here. Can't hit the, oh, that's not what I wanted to do. Go back. All right. All right, here we go. Just pretend that's connected. There we go. And back up. All right, so this could be something like that. You just kind of have to piece together the parts. Now, do we know where x attains its maximum or minimum values? It looks like we can conclude that f has a minimum value at x equals 1. But the maximum, I don't know, is it here? Is it here? Maybe that spikes up quite a bit. So we can't really determine that. So we're going to say f has a min at x equals 1. But we can't determine the max. All right. Example 8 is something similar to that. All right, our graph looks a little different. F is a continuous function, even though f prime isn't, f is continuous. So in what open interval is f increasing? Remember, f increases where f prime is positive. So we'll write that f prime is positive. So that would be from 0 to 2, it's increasing, f is increasing. All right, I know it says answer the following in complete sentences, so you should, but I'm not going to. All right, f is increasing on 0 to 2 and on 4 to 6, since f prime is positive on these intervals. Okay, where does f have a local max or min? So we're looking for where f prime changes signs. All right, f has a local max. Let me write that, local max. Remember, you're writing sentences. F has a local max at x equals 2, and also, even though it looks a little tricky, x equals 6, because f prime is changing from positive to negative at those values. And f has a local min at x equals 4, and also x equals 8, since f prime is changing from negative to positive at those values. On what intervals is f concave down? So we're looking for where f prime is decreasing. There, and that looks like it. So f is concave down on the interval from 0 to 3, since f prime is decreasing. And let's see, state the inflection value. Looks like the only inflection values we have, f has an inflection value at x equals 3, since f prime changes from decreasing to increasing. So it's decreasing to increasing. And lastly, sketch a possible graph. So this is probably the most difficult part for most people, but it doesn't have to be that bad. All right, we just have to look at what's going on. F is increasing from 0 to 2, and it's concave down. So we start at 0, 0. All right, we're starting at 0, 0. F is increasing and concave down. I mean, it's concave down to 3, but now we need to decrease. All right, so maybe something like that. Then we are still going to decrease, but we're concave up, and that happens until 4. There we go. And now from 4 to 6, we're increasing and concave up. So maybe something like that. Now remember, we're concave up for the rest of the time, so now we just need to decrease. we need to decrease. I think I forgot a part here, so let me add. Also, it looks like from 8 to 9. All right, so we need to decrease to 8, and we still need to be concave up. So we're decreasing and then increasing. So there you go. That would be a good enough graph of f. Now, can we determine where f has a minimum? Based on the way that it's going, we can determine there's a minimum at x equals 0, because it just kind of increases from there. Uh, and we can't determine where the maximum is. Maybe it's here again. We're not really sure. So we know that there's a minimum at x equals 0, and we can't determine the max. All right, so there you go. That's section 3.4.